We are used to thinking that the universe is made of things. Particles, fields, energy, matter. We imagine reality as a collection of objects interacting in space and time. Physics itself began this way, describing motion, forces, and material components. This picture feels intuitive because it matches everyday experience. But modern physics slowly dismantles it. As theories deepen, things begin to lose their importance. Particles stop behaving like tiny objects. Fields become abstract. Space and time themselves begin to dissolve. What remains is not substance, but structure. Not matter, but information. This is not metaphorical. It is mathematical. In physics, information is not about meaning or messages. It is about distinction, about what can be known, measured, or differentiated from something else. When two states are distinguishable, information exists. When they are not, it does not. At fundamental levels, reality is defined by what can be distinguished. Quantum mechanics makes this explicit. A system is not described by what it is, but by what can be known about it. The wave function encodes information about possible measurement outcomes. It does not describe a physical object in space. It describes limits on knowledge. Reality becomes informational before it becomes physical. When a measurement occurs, information is updated. Possibilities collapse into outcomes. What changes is not a thing moving, but the information available about the system. Physics tracks these updates with extraordinary precision. This suggests something radical. The universe evolves by updating information. Black holes made this impossible to ignore. For a long time, physics believed that information could be destroyed. Black holes seemed to erase everything that fell into them. But deeper analysis showed that this would break the consistency of physics. Information loss would make the universe unpredictable in a fundamental way. The conclusion was unavoidable. Information must be preserved. This means information is not optional. It is not secondary. It is not an interpretation. It is something the universe protects at all costs. Even when matter is crushed beyond recognition, information survives. This elevates information to a foundational role. Particles can disappear. Energy can transform. Space can bend. Time can distort. But information remains conserved. This changes the meaning of existence. Instead of asking what something is made of, physics increasingly asks how information is organized. What patterns persist? What distinctions survive interaction? Reality becomes less about substance and more about relationships. This is why space and time appear less fundamental. They may be ways information is arranged, not containers where things reside. Distance becomes informational separation. Time becomes informational ordering. Even causality begins to look informational, a correlation between states, not a force pushing events forward. At these levels, the universe resembles a computation, not because it is running code, but because it evolves by transforming information in lawful ways. The laws do not act on matter. They constrain how information can change. This does not mean reality is digital. It means it is structured. Continuity and discreteness become secondary questions. What matters is that information changes in consistent ways. Whether those changes appear smooth or granular depends on scale. This perspective explains why physics becomes increasingly abstract. Equations stop describing objects and start describing constraints on information. The mathematics survives where imagery fails. This also explains why intuition struggles. Human intuition evolved to handle objects, not information. We expect things to exist independently. Physics shows that existence itself depends on informational context. What can be distinguished, measured, or correlated determines what is real. At larger scales, information stabilizes. Objects appear solid. Properties seem fixed. The informational nature of reality disappears behind repetition and averaging. But at deeper levels, nothing is fixed. Everything is conditional. Reality is constantly updating itself. This does not make the universe unreal. It makes it precise. Information does not float freely. It is always tied to physical systems. But those systems are not primary. They are carriers. The structure matters more than the carrier. This is why physics can replace particles with fields, fields with strings, strings with equations, and still work. The form changes, the informational structure remains. Reality persists because information is conserved, not because matter is solid. This also reframes knowledge. Knowing something is not uncovering a hidden object. It is accessing information within constraints. Measurement is not discovery. It is interaction that produces distinction. The universe does not reveal itself fully. It allows partial access. Every observation updates information. Every interaction reshapes what can be known next. Reality unfolds as a continuous negotiation between possibility and constraint. This view removes the idea of a finished universe. Reality is not complete. It is ongoing, not because it lacks structure, but because structure itself evolves. Information is not stored somewhere outside reality. It is reality. When physics reaches this conclusion, it does not become mystical. It becomes careful. It stops asking what exists behind the universe and starts asking what must remain consistent. And consistency, not substance, is what holds reality together. The universe does not need things to exist. It needs information to remain coherent. Everything else emerges from that. Still within.